Hey, everybody, welcome back to the Doctor is In podcast. I'm your host, Dr. Nadia Saba. My guest today is Rob Eddy, the horticultural scientist for the Resource Innovation Institute, or RII, as you may have heard. If you haven't heard of RII, they are a nonprofit that has been developing practices, educational programs, and guidelines for CEA, all with the goal of increasing resource use efficiency. Rob is in charge of RII's educational programs, which includes writing those best practice guidelines, hosting industry working groups, and doing general outreach to help educate the industry. He's also leading the effort to develop a training and credentialing program for the CEA industry, something I know we all are on board with. Rob and I go back a ways, and way back before RII, when he was still the plant growth facility manager at Purdue, which he did for, I think, 20 years.
Hmm.
He is a through and through greenhouse guy. And Rob is someone I always enjoy talking to and talking shop with. There's a lot of topics we know that we could discuss, and maybe we'll have you back on the podcast, Rob, just to talk greenhouses. But for this episode, we're going to try and keep it focused on energy. Rob, thank you so much for being on the Doctors In podcast. I'm really excited that you are helping me launch a new series of episodes focused on energy in CEA. So thank you for being my guinea pig.
Oh, I'm honored to be on the Doctor's Inn and especially on this particular series that you set up. I think it's a great idea, and thanks for having me on early so I can help you kick it off.
Awesome. Well, I just kind of want to jump right into it.
Please.
So, we know that energy is a challenge in CEA. Most people quote it as their number two operating cost following labor, which I think labor is number one operating cost for any business.
Yeah.
But energy comes in as number two. And I was kind of hoping you could kind of help us lay the foundation, the groundwork for energy use in CEA. How is energy used to grow crops in an indoor farm or a greenhouse? Why is it so essential to run the CEA cultivation business?
Well, it may seem obvious, but sometimes to brand new listeners, they may not have thought of this, that you're trying to create a climate that's suitable for high yield plant growth all year round without relating about the season or the location. And that requires energy to do. It requires, a lot of times it'll require lighting. Most places in the country will require supplemental lighting. If you're indoor farm, of course, you need it all the time, uh, or at least 12 to 14 to 16 hours a day. And you're going to need heating and cooling, and you're going to need electricity to run pumps that bring irrigation water to your cultivation rooms, pumps to run fans to exhaust the air or to move the air around, and all the other ancillary activities that a greenhouse or indoor farm will do. Of course, like you might have coolers, you might have dryers. Of course, there's the operations areas. So you need a lot of energy. Even greenhouse less so, and we can talk about that, but still greenhouse is a lot of energy.
Okay, so you just described a whole bunch of different components and systems that use energy in pretty much any indoor farm, regardless of whether you are in a fully enclosed, walls and roof kind of a space where you have electric lighting year round, regardless of the season or what your sunlight levels are outside. But then also supplemental lighting if you're in a greenhouse. So lighting, climate control, whether it's kind of simple pad and fan or evaporative cooling or more sophisticated HVAC engineered systems, as well as those pumps and irrigation, to deliver our water and nutrients to our plants. But you just kind of hinted right now that maybe a greenhouse could use less energy than an indoor farm. Could you go into that a little bit more? And could you also just describe maybe the different types or sources of energy that would be used in a greenhouse versus a fully enclosed indoor farm?
Sure. Well, you're going to save energy in a greenhouse because you're getting sunlight. Now, it's an advantage. It's a big advantage. I've spent time trying to figure it out, and it feels to me like it's a 30% overall energy savings having that sunlight. But so it's not what you think as far as huge savings, but that's when I've tried to quantify it. Because to get that sunlight to come through your roof covering, which I may call glazing every now and then in this presentation, it's got to be transparent, and it's hard to get an insulative material that's also transparent. There's usually an inverse relationship between how much light it lets in and how insulated it is. So what ends up happening is your greenhouse in most of the country is going to need a lot more heating because its covering is less insulated. And so that takes away some of the savings you get from not having, like an indoor farm has, nice walls with insulation in them and built for really tightly sealed and built as a almost like a laboratory to be built. So yes, you do get savings in the greenhouse, not as much as you think. It's a trade-off with applying heat, particularly at night. Some of the energy types that you're going to use, you're going to get that thermal energy from the sun. Sometimes it'll be too much, depending on the season or the location, and you get too much heat, and you're going to have to use cooling to remove that heat from the sun. So the thermal energy from the sun is one source. There is with greenhouses, here's the trade-off, which is kind of tough on the climate, in that so far in the US, most greenhouses are heated using fossil fuels, using boilers running natural gas, let's say. Uh, Whereas indoor farms tend to be, this is a generalization, completely electrified. And so therein lies a bit of a problem, in that to electrify a greenhouse would take investment in technology that may not quite be mature yet. And of course, I'd like you to comment on that at some point in this discussion. Uh, so you've got thermal from the sun, you've got fossil fuel energy for your boilers for greenhouse, for example. Uh, you're probably all electric at the indoor farm. Then for both, you're going to have electric operating all the pumps, the lighting, the shade curtains if you're a greenhouse. So that's a quick rundown of the energy types. Am I missing one? Is there? Feel free to
No,
correct.
I mean, I think it comes down to fossil fuels and electricity. The question that then comes up, right, is sort of on-site energy production or generation versus off-site energy generation. So, like we might say, well, your greenhouse might need more combustion-based heating, to run unit heaters or boilers or something like that in the greenhouse, but an indoor farm uses electricity. But then it's like, well, where does that electricity come from, right? How is that generated? And it really depends state by state,
Yeah.
utility by utility, right? What the makeup of that electricity generation is, right? If you're in, I don't know, Colorado, you might actually be surprised how much electricity is generated by coal. Where, in Washington, it's, 98% is hydro, is, renewable water running through turbines. And so, it's a much cleaner energy. So, yeah, this question, people will bring it up. Well, why do we want to electrify when we're just going to be burning, right, these fossil fuels somewhere else? Isn't it just the same?
Yes, totally. One thing you could say about that is those coal burning plants are they're actually more efficient at it than you could be if you were if you were had your own fossil
Yeah.
fuel production. I'm not quite saying that right, but I wouldn't. There is a certain efficiency you get from municipal run power generation
Right.
because they're professionals that have been at it a long time. But yes, it is a problem. Well, the goal is let's electrify everything, but let's get everything the grid on renewable energy. But that's not going to happen quickly. It's going to be quite a lift. So it is a bit of a trade-off. You do have to look what the source is. But still, I kind of lean towards electrification just because what I said to open with, that those power plants will hopefully keep getting more and more efficient.
Yeah, and I mean the amount, if you wanted to implement renewable energy on your site, the amount of acreage you would need for solar panels or, for a wind turbine or some other source of renewable might be a little bit out of reach in terms of cost and land use and infrastructure and service and maintenance, right? Like it
Right.
just it balloons where if you can work with a utility or within your state that is building up the renewable energy supply to the grid, then you don't have to worry about running that extra power plant basically on your
Um,
own site. With greenhouses especially, we've had some clients who have come to us saying that they want to electrify their operations, and they might start with their fleet of vehicles, and some other processes that are maybe low hanging fruit.
mhm.
But when it comes to their greenhouses or their research greenhouses, right, they have all these gas fired units, and switching to electricity, especially when you are in a rural location, right? Where greenhouses tend to be is an
Mhm.
extra challenge because, um, how do you get that extra electricity to your site to run a heat pump, right? Or an electric boiler or an electric something that is providing the heating rather than a gas boiler. And the utilities that we've talked to have recognized that that is a challenge, especially for agriculture, that asking farmers to switch from propane or natural gas to electricity is not only going to be hard infrastructure wise, but also the cost. Like, do they actually have enough power running to that farm? What is now going to be the cost to bring an extra transformer, an extra line to that rural site just so that they can electrify their greenhouse? So there are a lot of barriers to get over, I think, before many greenhouses and rural farms are fully electrifying their operations. But it does seem like that is the trend that we are moving toward.
Right. And as all your audience knows, if you need a lot of power somewhere, it might take a long time before the utility can get it there. So it kind of
Yeah,
interferes with your business plan. And also the barrier would be managing risk or the perception of risk, and that it's it, if if you've got to rely on the municipality, can you for all of your power, and if you don't have it, you don't grow plants and you lose a crop. I mean, that's you have to have faith in that utility they're going to be able to do that. Whereas if you have some of your own generation there on site that you're used to using, or natural gas, municipal natural gas tends to be more or less risky because it's buried underground. You don't. I've heard of outages just once, but not very often. So it'd be hard. It'd be hard to let go of your reliable natural gas supply for electricity when in there's so many electrical outages for various reasons.
for sure. And we know that if you're growing a plant indoors or in a greenhouse, if you lose power, if you don't have a source of energy to run some fans, forget the lights, turn off the lights. But if you don't have any
Yeah.
power to run some fans and just maybe ventilate your space, it will become a swamp, and very quickly you will lose your crop if you don't have some backup power or some backup plan.
Yeah, I managed a research greenhouse for 20 years and many nights. Luckily, Not a whole lot of them, but where we would lose power in winter a couple times in, sub-zero. And it's only a matter of a few hours. I mean, uh, so I mean, I had occasion where the whole greenhouse got down to 40 degrees or something like that. Be surprised
Yeah.
that we didn't lose more plants than we did. But when you're doing research, you got to worry about what happens to plants when they experience that sort of shock, and does it impact what you're trying to measure on the
Sure.
plant. But it is a scary thing. And in the heat of the summer, and I wasn't even located in a really hot location like the Southwest. I was in the temperate zone. But boy, if you lose power, you're running around opening doors and vents. You could probably get away with certainly longer than a few hours. But it's a reality, and it's scary. And if you lose your pumps and your automatic irrigation, and you're a massive greenhouse, there's no way you probably don't even have enough hoses laying around to ever even reach those crops. So you're in trouble.
Which is, I think, just on that note, one of the benefits of if you're growing lettuce to grow in deep water culture, right? Because those roots are always submerged in
Yes.
water and nutrient solutions. So if a pump does go out because you have a power outage, you don't have to worry as much about delivering water continuously to those roots.
Yeah, as opposed to aeroponics, where I've only done a little bit of aeroponics work, but my goodness, how long? It wouldn't be very long to lose
Yeah.
that pump in an aeroponics operation.
I bet aeroponics operations have generators.
Absolutely. And
Um,
backup redundant pumps and redundant, yeah.
yeah.
So
You
that they
know, since we're talking a little bit, I mean, we're touching a little bit on location just by talking about being rural versus being urban and your access to energy infrastructure, but also whether it can get really cold in the winter or oppressively hot in the summer. How do you see energy use being impacted by an operations location? Do you think that a facility in the South necessarily uses more than in the West, or that in the cold North that maybe they use more energy than in the Southern U.S.? Or do you think it goes back to that type of energy that we're relying on and how much of that energy we'd be using?
Yeah, and I'm glad you asked that. To me, you're definitely going to use more energy in the north. Now, one of your listeners might disagree, and I don't have metrics in front of me, but like I said, the problem is uh, you're using fossil fuels. The north is you're using more energy up there, and when you're heating, I'm going to go out on a limb here and say, yeah, it's going to cost you more to heat than to cool a greenhouse, for example. Let's stick with greenhouses, because all you really need to cool a greenhouse are fans and vents. That's not quite good enough. Then you need evaporative pads, and those work in a certain portion of the country, and we can talk about that as far as regional as well. But most greenhouses are not using mechanical cooling like gigantic HVAC units to cool. Now, and 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 I'm old enough to be able to say, 30 years ago, that wasn't a thing except for
Never.
Monsanto and Bayer, Dow
Sure,
AgroSciences. A
yeah.
few of them had it.
For
But
research
for
purposes, right?
research
Yeah.
purposes, and they had deep, deep pockets with very expensive products to justify it all. Now we're seeing more HVAC greenhouses. I'm thrilled by it because I like technology, but most of them aren't controlled. So if you have to cool, you're using equipment that's not all that effective at cooling to your set point in the deep south or in our heat wave condition. But it's certainly not using up as much energy as an HVAC unit would be for an indoor farm. I hope I've answered your question there. I'm
Yeah,
trying
I
to give you an
mean,
idea.
and I think also in the north, one of the benefits that I see of a greenhouse in a northern climate, if you can find a sunny location,
Mhm.
is the greenhouse effect. Right? I mean, I think that a lot of people don't realize that the greenhouse effect comes from greenhouses. Like that term comes from the
Yeah.
greenhouse.
Yeah.
And the reason that it works so well in the north is because, right, those sun rays come in, and then especially with glass, right, glass is opaque to that long wave radiation. So that long
Right.
wave radiation just bounces around and generates its own heat inside the greenhouse. So if you can find a greenhouse location that is sunny most of the time, like even I think about, Denver or Colorado, like it could get cold, but it's also very sunny, right? 300 days of the year or more, it's sunny, and it's dry. So, what a great spot to take advantage of the greenhouse effect and be able to use evaporative cooling when it is warm because it's dry enough. Montana, another great example. And I know, we have so many microclimates around the US. And I would just really encourage people to look at what the available sunlight is when choosing your greenhouse location, if you can choose, because then it can lower those heating costs, right?
Excellent. Yeah, because and you can do that easily with the DLI map, the Daily Light Integral map that Jim Faust at Rutgers first published what 12, 15 years ago and
Yeah,
has been
yeah.
updated recently. So you can, that data is there for you. So you can. I'm so glad, Nadia, you mentioned lighting, because of course that should have been the second half of my answer to the last question, that up north you're gonna need more lighting. So that's gonna cause you to have to spend more electricity. And I will validate from personal experience about the greenhouse effect, in that a lot of times when I'm introducing someone to a greenhouse, or went back when I worked in one and I was training people, they were kind of surprised that we had to cool in winter. So, oh yeah, it gets hot. If the sun comes out from behind the clouds, yeah, the cooling's gonna have to come on. Now you got to be really careful how you do it, because you don't want to do it in a way that you're bringing in 20-degree Fahrenheit air.
Yeah.
It's plants, 3 feet away. You got to be careful about it. But it is true. And the other thing that we noticed as well is uh, invariably every spring, early spring, like March, it'd still be freezing cold. I moved in Indiana, close to Chicago. Think about Chicago. It'd be freezing cold outside, and yet. We noticed that our watering crew would miss more plants are drying out in the greenhouse because they were gauging their watering. If they're doing hand watering, they're gauging it upon the weather in the season. But now they hadn't realized that the sunlight is kind of sneaky. The sunlight gets much brighter before it starts warming up outside. And so it's just one of those things
Interesting.
it's just one of those things that you learn about transparent buildings, much like you talked about the heat building up inside of it, but also just the fact that it can be elusive in what's going on in there.
Yeah. Wow. That's that's amazing, and such a good story to tell that yeah, it might still be chilly out, but if the sun is shining, then you have that radiant heat, which feels warm. And your plants are certainly going to feel warmer under that extra radiant heat. Which brings me to a question I have
Mhm.
to ask you, which is the debate, and maybe the debate's over, I don't know, but between high pressure sodium and LED lamps in a greenhouse specifically. If plants like that radiant heat, right, or can benefit from it, are we doing any sort of disservice to our plants or to maybe greenhouse heating by switching to LEDs? Maybe in these northern climates where it's cooler.
Yes, some of the highest tech vegetable growing greenhouses, particularly vining crops, being built right now. You can see that they've decided on having HPS, a mix of HPS and LED. HPS to do just what you suggested, to radiate heat to warm up those leaves. And then the LEDs, of course, to provide supplemental light or certain spectrum of light for low efficiency, I mean high efficiency lighting. And then you're seeing these, they maybe even use the LEDs intra canopy, where it's close to the leaves, and you can get even more light use efficiency because you're getting more interception of those photons because you're intra-canopy, and then the HPS are overhead. So to me, the argument's kind of over. LEDs really do win the day, but there are certain times when they have been proven, or HBS has been proven still to be the in combination with the LED to be the better to be the better choice. But I say this with a little bit of hesitation because you really have to the folks who decide to do that are really high tech growers and understand
Mhm.
the science of it. And they've taken the measurements and then done all the work to determine that is the way to go.
Yeah. And when I've talked to greenhouse growers in northern climates, it always surprises me. Maybe it should stop surprising me how many of them say that we have plenty of heat. We don't need any more heat. We need to figure out how to cool and ventilate and control humidity in this greenhouse, not how to heat it. So if we can take away one of those heat sources, being the high pressure sodium lamps, then maybe that's a good thing at the end of the day, because that's one less heat source that they have to try to vent or cool from the greenhouse.
Right.
Yeah.
Right. I agree. I agree. And if you think about it long term, the savings on the energy from not using HPS but using LEDs, that's going to be saving you some money that theoretically you could use for investment in some of the other energy saving equipment to keep your greenhouse optimal.
Yeah. So, just to kind of shift gears a little bit, but always on the topic of energy, do we have good data, Rob, on how much energy a CEA facility, regardless of what type or what crop, how much energy these facilities are using?
Heavens no. And this coming from a guy who works for a nonprofit organization who that's part of what we do. It's a big part of
Yeah.
what we do, trying to benchmark the use of energy in CA facilities because you can't get any improvement if you haven't benchmarked it.
Yeah.
If you don't know what the baseline is. But it's so elusive, and let's dig into why. One is uh, probably more so in the United States than some of the other markets or globally. Our greenhouses are diverse, been built by a lot of different styles, a lot of different equipment, a lot of different ages, of course. And then we're such a big country. We have so many different climates and microclimates that there's just no standardization, really. I shouldn't say none, but there's not much standardization. So even if you're capable of collecting the data, it's really apples to oranges so often. And that's not even talking about indoor farms. Indoor farms are such a new technology. Of course, they're not standardized. And so layered in that problem is the problem of no one wanting to share information, particularly indoor farming community, which is a new emerging market, and they want to hold their cards close to their vest. Uh, they've been very generous with data, some of them with us. We did release a report where we benchmarked 12 facilities, both greenhouses and indoor farms, but 12 isn't a big enough number. The only thing I can tell you that we were meticulous about it, and I know you'll probably want to know what some of the barriers to all that was, but we're meticulous about it. But with that small of a data set and that much variability, it's difficult to draw any conclusions or say, here's the number. But what we did do was there have been some published reports from academia using modeling or using some smaller scale measurement. And actually, our numbers lined up pretty well with those citations. That made us feel like, okay, that was definitely well worth it.
Okay. Yeah, we did a study here in California as part of our code readiness work that we've been doing with the Energy Commission here. And we went into 10 facilities in the state of California, indoor and greenhouse, mostly cannabis, because ironically, cannabis is more willing to work with us than vegetable growers. It's beside me. I don't quite understand that. But Like you said, 10 or 12 of these facilities is not enough. And in California, we have a lot of climate zones. I'm sure, like, and we hit multiple climate zones just with our 10 facilities. And I'm sure, if you had 12, they were all over the country, that would be even more diverse
Yeah.
what the climate zones and the practices are. And you're right. I mean, what conclusions can you really draw from a data set of 10 facilities? I will say that greenhouses were consistently using less energy overall than an indoor farm. But I think what was surprising to us is that, one of the indoor facilities that used high pressure sodium lamps use less energy per square footage basis than an LED farm.
Hmm.
And we were really surprised by that. But when we looked at the type of systems, the type of controls, and the type of person who was managing the system, that's where we really got a feel for this is more maybe about the operational decisions than it is necessarily about the equipment. The high pressure sodium lamp facility was all decoupled equipment, dehumidifiers and split systems. Like that's
Yeah.
what everyone's trying to go away from, right? And the LED farm had the integrated HVAC with dehumidification and, blah, blah, blah. But the high pressure sodium grower, his background is in energy management. And the LED grower, his background is construction management.
That's good.
And so one is literally about operations and the other is literally about building, right? And so just like how many people are taking into consideration the user, right? I feel like when it comes to energy codes and standards and things, like there's a lot of talk, a big push for more efficient equipment, right? Or certain types of glazing and envelope and everything. And they really shy away from the user and establishing rules for how you use that equipment. I completely understand that. But there is a nuance, right, to running these farms, to running any building, right? Or any a car for that matter, right? How you drive your car. Do you always drive it at 35 or are you racing to every stoplight, right? Like one is going to use more energy than the other. For me, one of my big takeaways from our study was don't forget about the user. The user is probably the biggest variable a lot of times, not just the systems and equipment and the building and the crop, and the location. Those are all the things that we like to think that we have control over, but there's a person behind the wheel in every case.
Absolutely. You have to someone who has time and the curiosity, and as you mentioned, the background to actually look at it. And then you got to hope they have a way to even get good data from their own facility. If they only have
Yes.
1 meter, how are you going to know if something you did in cultivation really saved you energy? I mean, you might, but that is a problem as well. And of course, there's sub metering. We won't get into all of that. But the problem is those things stand in the way as well. And going also along with your point, what our data had shown, both both in cannabis and in the few number of CEA facilities, is the longer you'd been in business, well, you could track that your efficiency, your energy use, your efficiency is going up the longer you've been in business.
Mm.
Carmen keeps pointing this. Carmen Azzaretti, who is in charge of a lot of our data analysis, she has seen this. I'm also going to confirm what you said about cannabis growers. We have benchmarked hundreds of cannabis facilities. They're totally willing to share that information. It's just the other parts of the industry that aren't. And we see that, she tells us we see it clearly. So the operator, like you said, the operators in their experience is just so important to all of this.
And you made a good point too. I mean, okay, so do you have the data to make decisions, right? Data-driven decisions. I mean, it's one thing to have the data, whether it's from 1 meter or sub-metering, or you have a BMS system that can, collect the data and maybe even do a little bit of analysis for you. But do you know what to do with that data? I think that seems to be another big barriers. One, we don't have enough, we don't have the data at all, or very little data. But then what do we do with that data? What's it telling us, and how do we make decisions to be more efficient or optimized with the data that we do have? And we ask a lot of a grower, of these operators to wear many, many different hats. And, at least from my perspective, from HVAC and climate control, that seems to be the biggest black box for a lot of growers, right? Like they understand lights and spectrum, and, they can see it dimming. I mean, that's very intuitive. They seem to always want to play with nutrient solutions, right? And different fertilizers and waters and shots and delivery rates, et cetera, right? Like that is like a lot of their art to their growing. But when it comes to managing temperature and humidity and VPD, it's like, oh my God, if I could just flip a switch and it could do everything for me, I'd be happy, right?
Yes. Yes.
But unfortunately, HVAC is a huge portion of the energy use, right? I mean, what have you seen in terms of just like a simple breakdown of lighting versus HVAC versus everything else?
For greenhouses, the lighting is about 40%, and for indoor farms, 55, 60%.
Mm-hmm.
That makes sense.
Yep.
40% versus, let's say,
But
60.
even 40% for a greenhouse seems kind of high for getting free sunlight, right?
Exactly. Yeah. Yeah. Exactly. Great point. I'm glad you're emphasizing that, because a lot of people, to me, it's sort of like, yeah, it's a given, but it's not a given to folks who haven't worked in a greenhouse. And then for heating, for a greenhouse has to do a heck of a lot of heating. Of course, it depends on where you are, but you tend, even in warm places, parts of the country, they can have cold nights, particularly in a desert location.
Sure.
So 40% of your electricity is heating in a greenhouse, and this is great for an indoor farm. It is way down there. I have to, like, less than 5%, because they're getting so much of that. They're so well insulated, and
Yeah.
there's so much heat coming off even the LEDs. People have to remember that too. LEDs, it's not like they're not giving off heat.
Yeah.
They're just getting off less than half the heat of an HPS. Is that about right?
Yeah. Yeah. Yeah.
Yeah. So you're still giving off a lot of heat. So and with cooling, of course, that trend that segues beautifully into cooling, because that indoor farm, they're really focused on cooling. And greenhouses, this is a generalization, are kind of more focused on heating,
Mm-hmm.
for the reasons that we're laying out these percentages. But maybe 20 to 30% of their energy is on the cooling, just to trying to bring that down. And when you add dehumidification into that, I've separated them out there. In this is now you're up to maybe 30%. So you're spending a lot of time and a lot of energy trying to keep that place cool. Whereas in a greenhouse, you're spending a lot of time trying to keep it cool, but you're just using exhaust fans. Again, you're typically not using uh, big mechanical HVAC units. And now you can buy dehumidification units, kind of the same thing, but you can buy ones particularly made for dehumidification that actually sit in the greenhouses. But those are very rare as well.
Yeah.
And then
Yeah.
all the other stuff is kind of minor compared to those three: lighting, heating, cooling. For both of those, the types of facilities use up what, 85%, 90% of the energy, and the rest is kind of small pumps for irrigation. But it's just a little bit of a trade-off between the more lighting in an indoor farm, more heating in a greenhouse, more cooling in an indoor farm.
Yeah. Yeah, what we see for HVAC, cooling, and we tend to lump cooling and dehumidification together, because in in a lot of cases, right, you need to do the cooling in order to do the dehumidification if you have an integrated package DX unit or if you're using chillers. But also, if you're using a decoupled system where you have a dehumidifier and, an air conditioner, that dehumidifier is generating heat that you then have to cool. So you can't just let the dehumidifier dump all that heat of compression back into your farm, or else it's going to be sweltering in there. So, when we think about lights, the lights are the energy, right? That's going into the facility, yeah, there might be some ventilation or some envelope loads or something. But for the most part, right, I mean, 95% of the energy in that indoor farm is from the lights, and the plants are absorbing some. The surfaces and the materials in the room are absorbing some, but probably about 90%. So if we say that lighting is, say, 50%, then 50%, 90% of 50% that we have to remove is now 45% cooling and dehumidification. So it's almost equivalent the amount of energy that we have to take out of the room that we put into the room, right? In order to balance the energy. And a lot of people don't realize that that is exactly what we're doing with an HVAC system, is trying to balance the energy that we put in or that left, right? In the case of heating, right? We're adding energy back in that left through that glazing or through ventilation or whatever. So, and the same is true for a greenhouse, right? We just turn on fans to suck that heat out. We don't do that in an indoor farm necessarily. We could with air side economizers, but if you're also trying to control CO2 or, stuff getting in, then maybe you're less willing to ventilate your indoor facility. But if we do it with a greenhouse, I don't know why we couldn't do it with an indoor facility.
Let me jump in and just say, because this kind of goes back to one of your other points. I loved your description there. And I'm in this business, been thinking about this a long time, and I still can't explain things to that clarity. But this goes back to what we're talking about, the operator, in that when I was young, all you needed to be a greenhouse manager was to be a horticulturalist. And you might have a mechanic who'd come in and fix some stuff for you. Or if you're at a larger facility, maybe there's a maintenance team and maybe, even got some HVAC, but someone else is doing the PM.
Maybe. I like how you said that.
I knew nothing about how refrigeration worked. And I was 40 years old and I went to a clinic that Conviron growth chambers were putting on. I remember raising my hand and saying, I was the only person in the room who didn't know how the refrigeration cycle worked. And they stopped and they explained it to me. But that is an example of part of the problem. Nowadays, you need to be more than a horticulturalist. You need to understand physics, like you were just describing. You need to understand how HVAC works. You don't have to. People don't have to understand as well as you do, but they need to develop a sense. They need some of that information in their heads, along with their passion for plants. Sometimes a facility is lucky and they can have enough employees that they can specialize. But like you mentioned earlier, sometimes the grower it has to wear too many hats and they don't understand how that works. And I'll make fun of myself to give you another example. The controller that I had at Purdue's greenhouses, one of the advanced companies, I had to call, well, when they were doing some troubleshooting on the phone with me, they said, well, we'll take a multimeter out there and measure the resistance. And I said, I don't know how to do that. Can you teach? So over the phone, these guys,
Yes.
I got the cabinet open for the controls, and I'm using I knew I had a multimeter, but I didn't know how to use it, and they taught me how to use it. I was 35 years old and didn't know how to use a voltmeter, a multimeter. And so I'm using myself as a case of how far we've come. That these are very sophisticated, very, very sophisticated facilities with such a dynamic environment that it really takes more than just plant passion.
Yeah. I mean, you were playing electrician right there,
Right.
right? I mean, we have talked to a few growers where they are manually controlling everything, like literally flipping switches to turn
Wow.
on and off fans. Have you
Wow.
ever worked in a greenhouse like that?
Yes, I worked in a greenhouse that was passively controlled completely.
So was that like an openable roof vent and you would just like
Yes.
push a button and
That's
it
all
would
we could do.
open or
Pull a
close?
chain. Pull a chain.
Pull a chain, even
Chain gear.
better.
Okay, so this, and then when I was at Purdue, I found a document that was the instructions to the weekend watering team from back in the early 70s. And the instructions were something like this: listen to the radio, and it gave the radio station twice a day, And depending on the weather, and they would give some parameters of what the weather person said on the radio, and then they gave a list of each greenhouse, and they said, turn this steam valve a quarter turn to the right, a little bit more steam, and open this vent halfway. I mean, the whole greenhouse was controlled manually, and a person can do it. It gives you huge swings in temperature, but you can survive. It's hard to imagine someone could do it these days with the quality that is required of
Mm,
both medicinal crops and food crops and flower crops, that you could keep up with that without completely burning yourself out.
right. Do you think that there would be benefit to growers going through that sort of rigmarole?
Rigmarole.
Yeah, where they had to, I mean, be paying attention to what the temperature is, what the weather guy said on the radio, and to the age of their crop, or to some external variables, I guess, and follow this sort of outlined instruction or SOP per se, right? The standard
Right.
operating procedure for what to do. Like, if this, then this. Do you think that there could be some advantage to the grower who has to go through those manual
Yep.
operations to get a feel for the greenhouse and then apply that to a sophisticated control system?
No, I think would be valuable, and it's probably true with a lot of greenhouse operations that you tend to have different phases of building. And you might have an older building with a step controller in it, right? And let's talk about a step controller. Some of the early step controllers are simply this. It's like integrating a bunch of thermostats into one box. And so the thermostats, they kind of know what each other are doing, but you set the temperature at which a fan comes on, and then you set the temperature that it turns off. And then the next fan, you do the same thing, but you want to have them slightly different. So they're not coming on both at the same time. You're staging your cooling. And so you plug all these numbers in manually. And then the same thing with heating. You say, I want the first unit heater to come on when it gets 1 degree below my set point, and turn off when it's at 0 degrees below set point. And the second unit heater, and you say,
Yep.
come on at 3 below the set point. And then the perimeter heat, which is my big slow heat, maybe I have that wait till it's -5 or something like that. And you tweak with that, and you begin to learn. As long as you've got to have a graph, though. You've got If you don't have a graph, I don't know what you're doing. How do you ever learn from that? So I was lucky enough at Purdue that I had a brand new facility with super advanced controls, but I also had a polyhouse built at the same time that
Mm,
well, not the same time, built a year later, that they didn't have the funds to put in the fancy controls, and I had to learn how to do a step controller. And that made me learn so much, just like you said. And it also
yeah.
made me appreciate my controls that were more advanced, because the particular step controller I had would not adjust things according to sunlight. And the bottom line was, I was having to go out there. It was better than setting thermostats, certainly
Right.
better than opening vents and turning on steam valves, which is primitive. But the step controllers, I was having to go out and make adjustments every 2 weeks according to how the seasons were changing.
Yeah.
Whereas the advanced controls, I only changed anything unless we needed to change the temperature for a research purpose, 3 times a year. Yeah, 3 times a year. That was it. I literally did not have to. Once I worked it out, it really took care of itself. Like, you
Yeah.
didn't have to tweak with much of it, because it was measuring the sunlight, doing and making adjustments based on outdoor temperature and outdoor sunlight and all of that. Long answer, but just
No,
thought.
I mean, I really want to go off on a tangent just off of that, and I'm trying to decide whether I will or not. But it just makes me feel like where we are right now, even with AI and automation and that whole discussion, is, there's this debate or this discussion about how we could integrate AI and automation into CEA. And, just this whole piece of how important is the grower now, right? Do we need a grower to be monitoring the AI data driven decisions, Or is the grower intervening if there's a problem or monitoring what the AI is doing on a consistent basis? But it just feels like what you're describing, and I use a SEP controller for my PhD research, though, was a little bit more sophisticated than that, but I definitely had to set different set points for different times of the day or different seasons, and would get frustrated that I couldn't do two functions at the same time, right? It was like you're either cooling or you're heating. You can't be doing cooling and heating, right? Or cooling and humidification, like, does not compute literally. So you learn what the limitations are, but that has helped me so much in diagnosing the problems or the challenges that growers today are having. And they have these very sophisticated systems, but I sit back and I look at, well, where did you come up with that set point? Where is that operating schedule coming from? Don't you have a deadband? Like, there's just like certain things that are very, I think, intuitive to me, because that was my first experience, were these step functions, and where I had to program everything and think about what stage one, two, three, four meant in terms of operating the equipment and what response I was trying to get out of it. And even saying, okay, I'm at stage four cooling. I can't get any more cooling out of the system. What does that mean? Does that mean it's just going to stay on all the time? Do I have a time limit deadband? Do I try to bring things down, right? Like, what do you do when you hit your ceiling? And I see a lot of growers kind of hit these ceilings and they don't really understand where those limits are, or what they could maybe program a little bit different to get a slightly different response. And I don't know that the controls vendors are necessarily even doing a good job at educating the growers who are using them, or maybe it's just a lack of user experience, and they don't know how to. But then when I think about that leap into AI, I'm like, well, if growers are already challenged with understanding the settings and the outputs that they have now, like, how is that going to get even magnified more when we introduce computer driven decisions, not human driven decisions?
Yeah, the analogy I have for that is GPS car navigation. That um, you and I have lived when we could drive, when we drove without that. And you would develop, some people better than others, but you develop kind of a sense of where you were in your city
Yeah.
and where you were, kind of the road. Whereas my kids, who are good drivers, but they kind of, when they're going anywhere new, they're relying on that GPS. And so they just don't have the innate orientation to where they are. And that's never coming back. So I can see where you're going with this, that if we have AI, the grower could lose that sense of how they got there, of why
Yeah.
why is it doing this? Why is it doing this? So I agree with you. It could be a problem. I think I'll try to temper that with more positive news, is that AI will probably not be so much black box machine learning where you don't know how that AI came up with that decision to do it. I think people recognize, like, we need to limit that because we need the results to be explainable so that the grower, like you're saying, understands why it made that decision. So let's develop AI based on crop modeling done by professional plant scientists who understand physics and understand physiology. And so there are rules that the AI has to follow, and that will then help that be explainable. So I'm hoping that is how we avoid having a generation that doesn't understand how greenhouses work.
Yeah. Um, just on that driving comment or experience, this was several years ago, maybe 10 years ago now, and I was meeting a colleague at a project site. And I generally knew where I was going because I was from the area. And so I just couldn't remember what the exit was that I needed to take, as either this one or the next one.
Yeah.
And so I call my colleague. I'm like, hey, which exit did you take? And he's like, I don't know. I just went where my car told me to. And I was appalled. I promised myself I would never
Yep.
put myself in that kind of situation where I have no idea where I am, what exit I take. I mean, just for emergency purposes, like
Yeah.
who are you going to tell? Like, where are you? And you're like, I don't know, and oh, the way my car is broken and the GPS is broken, so I can't tell you that either. So I just,
Right. Right.
yeah,
Right.
I don't know. Okay, so let's move to best practices.
Sure.
So, RII, you guys have put together a lot of best practices guidelines. I mean, it seems like there's another one coming out every few months. I'm not even sure I have them all. I think I have like 7 of them downloaded. Could you just I want you to just talk about what those guidelines are.
Mm.
Why those particular ones? Because it's not just like savings with lighting. It's not just utility incentive. I mean, it just runs the whole gamut. So if you could just give us a background on how you chose those guidelines and maybe even just the process that you guys have gone through to develop these.
Sure, I think it's evolved because the first ones needed to be kind of targeted, and I wasn't at REI to understand what the exact decisions were. But of course, the first ones that came out, well, REI was founded in 2017, I believe, and the first few years were serving the cannabis industry. And so that's a different audience. That's an audience that are really good growers, but haven't grown. A lot of them hadn't grown at scale, and so you need to talk about what are the best practices for lighting at scale, the full scale, and what are the in HVAC. And so those were separate ones that RAI wrote to focus on those particular equipment types. It's evolved a little bit into the integration of that stuff. And we're always trying to build in resource efficiency. So the first one that I took part in was water circularity. And I didn't even know what water circularity was. I had to, ask my boss, was this, but it was, about recirculating water, treating water, using it efficiently, all of the 3 R's, reduce, remediate, recycle. And so that one was comprehensive, all about reducing water and what that takes. And it's a lot of technology that takes to do that. So we got into that, but it was kind of more integrated. And then we did controls and automation because again, I felt like personally, I'm very passionate about this, that really good climate controls and an operator who knows how to use them are really key to unlocking a lot of savings. While at the same time, of course, we want everyone to be making a profit so they stay in business or none of this is even relevant. And then from that, it kind of made sense. Once we've done controls automation, I wanted to get out ahead of AI and robotics. It was like the first time we decided let's try to do one where we're projecting what will happen. And so that one is what's going to happen in the next couple of years, what's going to happen within 10 years. What can we expect and how will that impact how we grow, but also how we can reduce energy and water and emissions. So that's a little bit about the evolution of the topics. The way it's done is we establish working groups, and these are industry subject matter experts. The one thing that REI does really well is we've got a broad network. And so it's growers, of course it's growers. It's vendors who make this equipment, of course. It's them and the construction industry. So now that's kind of interesting to bring that group in. The utilities, the utilities, bringing in the experts from those utilities, even bringing in, if they've got time, some policymakers from state governments, federal governments, and bring in and other folks, consultants, and anyone who we think might have relevant information, and anyone who is willing to share information, take off their corporate hat if they work for a corporation, because like you do with this podcast, we're not here to promote anybody's product or even choose winners. We're here to get pretty competitive information that will make the industry run better, accelerate the industry, or reduce energy and water use. So we bring them all together and for meetings, working group meetings by Zoom, just like you and I are doing, and we depending on the topic, it'll change anywhere from 3 to 6 meetings, and then I go away and I write the best practices guide draft. I give it to that group to peer review. What I tend to do, this is a little bit different than REI, since I'd come in, I wanted to really make sure I'm in touch with the academic community. So I'll try to see if there's an academic who's got time, and I've been lucky that I've been able to find that because academics are extremely busy, to co-author it with me to make sure that it is scientifically sound. So that's how the process works: is we have uh, the meetings, the writing the draft, the review of the draft from the group, co-authoring with an academic, and we'll also have some peer reviewers. Sometimes they're academics and sometimes they're from industry. It's not just to say, it's not a super formal peer review like you do for a journal or article. It's just a close review to make sure I'm not screwing anything up. And then we publish it. It's always been free. We are usually sponsored by, USD or DOE, someone like that. So it's all free. And then we promote it, and then we start putting all that information into our education programs, our interviews, training, all the stuff that other stuff that we do.
That's awesome. What has been the sort of feedback that you've gotten from growers and operators, or developers and investors, or utilities and regulators, from these guides?
It's interesting. It's it's what's satisfying for me, talking to people for the first time and hearing that they have downloaded the guides. Like I'll be on the meeting, trying to, whatever it is, and I introduce myself and what I do, and they'll say, "Oh yeah, we know we downloaded your guide." It's like, "Oh goodness, someone read it, okay, or at least they downloaded it." We're now tracking the downloads, and that's been exciting to see who is downloading them. I'm trying to think the kind of feedback that we get.
Has anyone suggested you add something in a future version of any of these guides?
Yes, they have. They'll say, "Yeah, I think uh, like when we did controls and automation, we touched on conveyance, we touched on machine vision grading, because I've seen that done, and I think it's a big part of CEA's future. At least I think so." And so I've had people say, "Yeah, that conveyance, there needs to be more explanation of how that works, where you've got not just a conveyor belt, but when you've got, as you've seen, automated gutters, for example, that have hydroponics in it. They move on themselves and they move into the packaging room, and it's all done." So that's one I can remember. The water circularity one, it was so comprehensive. I mean, I didn't find one that had been written for, but so it was. I tried to really make it comprehensive, and so I
Wow.
don't think anyone added to that. It was probably more of a, I think more of a goal of, can you make it readable? And that's always a challenge, is can I
Hmm.
bring this information? Because I'm also putting in citations from the scientific community. So we have industry informed content from the work group. We have scientific information. I love to write, bringing those together and bring them together in a way that anybody who reads Greenhouse Grower could understand them. That's the sort of language. So that's the challenge, is the more comprehensive you get, is it just too long? People don't have time to read.
Mm,
So I'm always looking for better ways to present these documents so that someone can go through them and actually absorb some of the information.
right. I would love to talk to you sometimes about water. My PhD was focused on water use efficiency.
I know.
Um,
I cited it
oh,
at
did
least
you?
2 or 3 times on the water circulator. Yeah, your evaporative pad stuff was music to my ears. It's like,
Awesome.
finally someone gets how much wastefulness these pads are, and why are we still using this 1930s technology? Okay, sorry. Just had to say that.
Because it works.
Yes, robust.
Unfortunately, it works where we don't have water, right? Um, but to stay focused on energy, I mean, could you list maybe one or two or three energy best savings practices related to any component or any operating strategy in general, or maybe as you were putting these guides together and working with these stakeholder groups, there are a few that just stood out to you that you hadn't thought of before, or maybe were really obvious and you don't think growers are implementing enough.
Well, I've got a bazillion things to talk
Of
about.
course you do.
You'll have to edit me down. But the one that struck me when I read it is, gosh, why didn't I know this before? ASHRAE had cited that loose fan belts, if you just keep are bad. If you maintain your fan belts so they're properly tightened, you can save 20% of its energy use. And if the pad is running, you save even more. You save 25%. So it's like, are you kidding me? I mean, just a little thing like that further brings home one of my themes, having been a manager of a facility, is that the people doing your preventative maintenance need to be your heroes. You need to learn how to recognize their value and recognize them. And that doesn't mean anything fancy. It means getting up out of your desk, going to where they are and saying, you know, I've noticed that we haven't lost a fan belt in 6 months. And I've just got to say, thank you. You're doing a great job. And that really helps me because I don't often notice it. Tell them why. Because as a manager, I don't often notice it. When these belts slip off, I may not notice it for 3 or 4 days. And then my low fan isn't running because of that. And now my high speed fan has got to run even harder. And I'm losing energy that way. And I'm getting bigger swings temperature. So you tell them what they do because it's such boring work. It's just preventative maintenance. It's not sexy at all, but you've got to learn as a manager how to create this environment where that is number one. So ASHRAE, that was a great thing. That was one that really stuck out. I'll first jump into low hanging fruit. Passive stages operating first. I mean, this is fairly simple, but if you're cooling greenhouse, if you've got both active fans, but you've also got a ridge vent, just open the ridge vent first. Have that be your first stage, just things like that. Passive stages first. Uh, some of what I'm going to talk about isn't necessarily reducing energy use, but reducing your peak rate, reducing your peak load, because not all utilities, but a lot of electric utilities will base what your rate will be based on what your peak amount uses. And staging your equipment, like lighting in particular. When I first started managing, I'd have all the lights come on, 6 a.m. Boom! How many ever there were? 200 lights coming on at one time, HBS lights. That is a huge spike. And so just go in my case, since I had a computer, you could just go in and just have them come on in waves over a period of, 12 minutes. Yeah, just kind of break it up a little bit. Things like that. Again, on the low hanging fruit in taking care of your facility, calibrating sensors. In my case, I had these little glass thermometers and for wet wicks and dry wicks, and I would just change them out every 2 years. I wouldn't wait for them to go out. I'd just change them out because they wouldn't get bad readings, but they just fail. And then sometimes you wouldn't notice, particularly if it was a humidity sensor. It failed, you wouldn't notice. If you're a manager, you know what I'm talking about. Your walkthroughs, you get pulled away doing other things, but just your walkthroughs are so important. Just determine, is this valve stuck on? Is this valve stuck open? And you learn from the signature of your temp and humidity line. Over time, it's great. You begin to learn what the problem is before you even walk out there. And that's what you need to take the time to do. And if you're not getting that time, then you need to talk to whoever is not giving you that time, because I could begin to recognize that fan one is off. We've lost fan one because look at this, I could tell. Or even stupid things like, I bet the back door is open. The emergency exit people would go out the back door and
Oh
forget
yeah.
to close it. Just things like that. It was like a little game. I'd think, I bet I know what this is. And then writing that down, printing when something goes wrong in your greenhouse, printing off that graph and writing it down what the problem was and putting it into a binder, because you think you'll remember that. Even if it's one that took you 4 hours to figure out what went wrong, I guarantee you, and as you get older, it gets worse. 8 months later, you'll say, huh, I've seen this before and I don't remember. how I fixed it. So, just simple, low-hanging fruit like that.
So you'd log the failure and the fix.
Yes,
I love that.
yes.
Love that.
Because I would, as fun as it sounds, several times I just said to myself, this has happened before. I've seen this, and I'm hoping no one around here is looking because I should know how to fix this, but I can't remember what it was. And so then I have to go through the whole problem solving thing again. And after that, I've had a couple times and I realized I just need to take, what is it, 5 minutes to print off that graph and then say, this is an indication of
Yeah.
how I fixed it. And so,
And
yeah,
then even in that case too, I could imagine like you mentioned like, oh, I've seen this before. And you go back and like, hey, this was 6 months ago. And then 6 months from now, you're like, oh, I've seen this before. And then then you start to see a pattern that, hey, maybe this failure or this thing is happening every 6 months.
yeah.
And then guess what? The fourth time you can anticipate it and you can maybe go fix it before it fails, kind of like you were saying with the thermostat.
Yeah, you put it on your preventative
Yep.
maintenance list. You have to have one of your own as the grower. Some people do preventative maintenance of your other equipment, but when it comes to the controls, it really should be you. And great example, if during your walkthrough, usually your sensor box is hanging there, and most often it has a fan. It's called an aspirated sensor box. It's bringing in air from the outside the box, so you're getting accurate reading. Those fans would go out.
Mm.
And at least at my greenhouse, there was no little light that came on, no indicator. And so what happens then? Your
Yeah.
box is now hanging in the sunlight without a fan bringing in fresh air. And so the temperature begins to, the reading goes up because that box is now hot. So your cooling is going to come on when it doesn't need to. Or if it's wintertime, you're trying to keep a certain temperature. And I'm sure that's how I caught it. I probably walked in some greenhouse and it is not 65 degrees in here. It is not 65. And then you go and you open up that door and there's that little the fan has gone out. And so there's the preventative maintenance, low-hanging fruit that the grower needs to do. Actually, I we checked the wicks for the wet wick reservoir. I hope some of your audience knows what this is. But we put it into the protocol when my team would go through. While you're checking the wicks, make sure that fan is running. And if not, tell Rob.
Interesting. Interesting. Looking
Yeah,
for the
and
wet bulb temperature.
yeah, and then like you said, doing enough observing, here's another strategy that happened was I realized, it's fan one that tends to break. The relays begin to kick out, meaning its motor is getting a little bit old or whatever it is. Whereas, well, it's because it's being used.
Yeah.
Like it's being used so much more than the other fan. So every year I would if I had two fans in my greenhouse,
Nice.
I would switch which one is number one, so that I'm evening out that wear. So I'll move on from low
Low
hanging.
hanging fruit. Okay.
And we'll start talking about upgrades. I know that I get this from AJ Both at Rutgers said that the activities that have the best ROI are lowering your night temperatures and investing in thermal energy curtains, shade and or energy curtains. Those are the two that he recommended just to start with. So the lowering night temperature, that sounds a bit weird, but you can raise your day temperature and still have the same average temperature. Turns out that that's a really good strategy that is now able to be done by advanced computer controls, and that they've realized you don't need to be chasing that temperature set point all day long and turning things off and on. It's okay if it drifts up and down. It's the 24-hour temperature is a better thing to operate on. You'll save energy that way. Uh,
Yeah.
and so upgrading your controls to allow you, it's not just 24-hour. I don't know anyone doing this, but they said 48-hour and even 72-hour temperature integration. That's what that method is called, temperature integration. Well, the energy curtain, apparently 30% energy savings potential from installing that. Condensing heating system, 15 to
Mm-hmm.
25% savings. Oh, just simple. And I know that you've written about this because it's a simple one. Of course, you do have to invest variable speed pumps and motors rather than things turning off and on.
Yeah.
It'd be extremely helpful. It reduces energy. So same kind of the same thought process as dimming lights. You just don't need all that energy on a fan running at 100% speed. Sometimes it's fine just at 50%, and that can save you some energy.
And variable speed components to me seem so obvious because it is a win-win situation, right? We win on energy savings, but we also win on managing, right, the climate or the condition, the variable that we're controlling by not having these spikes go up and down by turning something on that's really big and then turning something off that was also a really big, right? If I just thought about that fan, right? Like you mentioned, your number one fan, right? If it just kicks on and then kicks off, you're going to see these spikes and dips. But if it can ramp slowly on and off, then you get a much flatter curve. So to me, in both in terms of controllability and energy use, just makes sense. But I also know that it's not necessarily the standard componentry. And so that means that you might need extra controls wiring. You might need to upgrade your fan motor to a VFD or to an EC digital drive motor. And those all have costs associated with them. But, in our experience, if you look at what the return on investment potential is for that extra cost, for spending an extra, say, 25% for that, it could pay back in months. Like this is not like years and years of payback. This is a fairly quick turnaround when you know that you're going to get a more consistent, predictable crop without as much loss because you're fighting against humidity and temperature, right? If I, again, just thinking about the fan with those spikes and dips. So huge fan over here, variable speed, anything.
I'm so glad I'm so glad you brought that up. That's a great point. And you're right. Most greenhouses are not built with variable speed components, but hopefully, I think we're beginning to see some utilities beginning to offer rebates on that sort of equipment.
Yes.
Good. I'm glad you
Yeah.
can
And
confirm
that's
that.
positive.
And
And, I wanted to make a comment too on
yeah.
the passive ventilation because anytime I walk into an operating greenhouse, right, like one of the first things I look for, if I haven't seen it from the outside or from the drawings already, but is there a ridge vent?
Mhm.
Right? Can we open up that vent? And it's amazing how many closed roofs are out there for a greenhouse. And every time I see that, I just hand to forehead
Mhm.
and well, there's one energy savings opportunity I can just cross off my list of options, which is always unfortunate. It's another thing if they have it and they're not using it. And I
Yeah.
get that because they
Mhm.
don't understand how much to crack it open, when they should be cracking it open, under what conditions outside and inside. I get that, right? And so I'd rather you maybe not play with it until someone has taught you how to use it properly because it could end up using more energy if you're not
Mhm.
using it correctly. But not having it at all is such a detriment to these greenhouse growers. I'm not even sure why greenhouse suppliers are offering that as an option. I don't know, it breaks my heart to see
It's
those.
hard to fix and hard
Yes, it
it's
is.
hard to fix and hard to
100%.
maintain. That's the only reason I imagine because it whenever you drive by a garden center at a big box store or something like that,
Yes,
they
gotcha.
obviously don't know anything. And within the first year, you look up and their ridge vent is just open and all twisted and panes have fallen out of it
You're
because they
right.
got caught
You're
in a
right.
windstorm. But I had a greenhouse like that. And so at first I thought, oh, great, less time for me up on the lift fixing ridge vents. But here's what happened, which you can share with your clients. We basically cooked the shade curtains. Think about that. Think how much heat is accumulating up there that you aren't bringing down. I mean, the shade, the fabric for your shade curtains or energy curtains is once you get above 100. I don't know what it is. I shouldn't say what the specs are to your audience, but it was hot enough that those things it reduced their life. And
Yeah.
talk about expense and talk about time it takes to replace. Shade curtains are a nightmare when it's time for you to
Yes.
get up there and replace them. Or if you're hiring someone to do it, you have to move everything out of the way. and they're not cheap to do. So there you go. You get so hot up there, you can cook your shade curtains. It's another problem with them.
Yeah. And
And
I mean, you're right about the motors and the rack and pinions, failing and bending and all kinds of things that we've seen. But it goes back to your comment, the very first comment you made about preventative maintenance. You gave a very simple example of, the fan belt being loose and the detriment to energy efficiency in that. But unfortunately, so many of these greenhouses are not really given the proper love, and not just greenhouses but indoor farms, any CEA facility, right? It's the mentality of, if it's not broken, right, then we're not going to fix it or even monitor it. And now, it's springtime and we want to open up the ridge vent, and we go to open it, whether it's with the chain or whether it's with a button or whether it's with our control system, and it starts to creak open and then it seizes, right? And so then what? Like literally, then what? And most growers probably just, well, shit, I'm just gonna abandon that. I don't have a guy to fix it, and our maintenance team is busy fixing pumps that we really need to keep the plants alive. And this is just an added accessory. And since, we don't have the time and we don't have the resources and we don't know who to call, we just literally will leave it in that position. And I mean, I have visited greenhouses where like it's like just like permanently cracked open forever. Summer, winter, rain, snow, it's just like, and now your shade screen is catching snow.
yes,
So
um,
I get it. That maybe we avoid the ridge vent or the passive vent because it's an added maintenance and it's way up high. It's 30 feet up in the air, right? Who wants to get up there? But if we can implement, preventative maintenance programs, and I've been talking to greenhouse vendors and contractors too about like, we need to create service agreements, right?
yes.
Like operators are asking
Hmm.
for referrals. They want to know who to call when something breaks, or to be on a 3 month, 6 month maintenance plan with each season, right? You said that like there are 3 times a year that you needed to make an adjustment. So maybe there's a 3 time a year service contract that these vendors, these suppliers and contractors could set in place so that we are not limiting the growers' capabilities or options, features, right, in their greenhouse to save energy because it's just too hard and expensive to maintain. It's more expensive to not maintain it.
Oh yeah, and it's hard to convince the owners, whoever the owners might be, that they need to set aside money for maintenance. It's as simple as that. It's not sexy. Again, it's just not
Yeah.
sexy. But I'm a believer. Service agreements, yes, I have definitely gone to them as a greenhouse manager and extended warranties. And I never regretted it because, again, like you described, you're too busy with some of that stuff. And if you can pay someone to come in, once you've experienced the cost of some of these big repairs, and you can express that, what the bottom line is, and then give it to the decision makers. Hopefully that will help you get service agreements because you need someone to come in. If you've got shade curtains, the type with rack and pinion bars, you need those to be lubricated. And
Yeah.
it's kind of hard to do. Just hire someone to come in before the summer starts and have them lubricated because otherwise they get hung up and the motor keeps driving. And it's what I call train wreck. It just drives it until those aluminum bars are bending and your fabric is tearing and it's just a disaster that you can't do anything about until you get up there or someone gets up there. So yeah, long story to say, I'm a believer in that.
Yeah.
You could it doesn't make you a bad manager to realize that you need that sort of professional service.
Yep, yep. And I mean, you just think about your car. I mean, I'm sure there's people out there who never get oil changes, but or who never change their own oil. But I think most people know that we should, right? Every 5,000 miles or depending on what your car is. And as, I guess assuming you still have a combustion-based engine. I mean, even if you have an electric vehicle, I don't have one, but I'm assuming that there are certain preventative maintenance things that you're supposed to, do every 3 to 6 months or based off of mileage. You have to replace your tires, right? If you don't replace your tires, they're just gonna like fly off and you're gonna, it's gonna be a disaster. So, a lot of times I just use that analogy of your car and getting, an oil change or getting your car serviced every few months. And, when you do that, you increase the longevity of your car, you increase the fuel efficiency of your car, you increase your own peace of mind that the wheels aren't going to fly off as you're driving down the freeway, right? I mean, there's
Mhm.
so many good reasons to do that, and the same is true with your greenhouse or indoor farm.
Yeah, I think a good manager of a facility like that begins to recognize that their operation is like a ship. It's something that's cool. It's it's always running. It's always operating. It's very mechanical, and you just have to get into it and be proud of it. Part of that starts with the sanitation. You keep it clean, so that you're proud of it and you're proud of people's reaction when they come into it, and your employees seem proud to be a part of it. Then it helps you with wanting to do the preventative maintenance.
Yep, yep. So, Rob, just kind of to start wrapping things up, we don't have good standards in terms of metrics or how to steer the ship necessarily, and we get every grower likes to do something a little different or they have their own, art to the science. But what would you say are areas of need or gaps in our understanding and knowledge that we need to push in order to achieve efficiency, to achieve an effective CEA operation where we are achieving all of the goals, right? We're hitting our yields. We have a very quality product, and we're also not bankrupting ourselves to get there
Mhm.
through high operating costs. What do you see as some of these gaps that we need to get past in order to get to that future?
Well, like we said, so we don't have to go into it at length. Metrics, we don't have enough data, and we don't have the granularity of data. So that's something. So that kind of leads into an expansion upon that is how can we get more data without a huge investment of money, particularly so more people can invest in them. We have more companies doing it.
Yeah. I mean, I think we need to understand better how much energy or what are the outputs and inputs are from each of these rooms or components to really, once we get through the low hanging fruit,
Mhm.
is where I think that becomes sort of the higher hanging fruit in getting to that level of granularity. Because if I know my water treatment room uses X amount of energy and my propagation room uses this amount of energy, those are two completely different stories.
Mhm.
Right. So it's like, okay, so my water treatment room is actually using more energy than my propagation room. And maybe that's surprising to me because I thought cultivation was always using more energy. So now, you add this extra layer of asking the question, well, why? And does it matter that one is using more than the other when they're
Only, but
completely,
only because it would allow you then, if you make a change,
yes,
just in that water treatment.
to see how
Yeah.
that change would then
Yeah. Or
affect. Yeah.
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 Yeah. I should explain that better. We're like
Sure.
propagation. Great example. I think we could get a lot of benefit from focusing and upgrading on propagation, getting plants more light, better care, because it makes sense in propagation. It's better light use efficiency. You got a bazillion plants in a small area. spend the money to light them up well. And there's been some research that shows that there's a carryover effect of quality from being treated very well as a young plant. So
Yeah.
therein,
Yeah, yeah, yeah.
that'd be an example of something you could kind of use those for. But I digress. Did you want more what I believe are barriers, or did you want more of where the research needs to go? Let me know.
Well, I mean, I think they're sort of interrelated, right? What the barriers are and where the research needs to go in order to fill those gaps. So, I mean, feel free to speak to either of those, but really what I'm trying to get at is, how do we, what's the roadmap to getting there? And I
Oh, yeah,
guess, what
yeah,
hurdles do we have to leap over? And I don't know, crocodiles in the swamp, do we have to jump over
yeah.
or avoid?
It's hard to get research done at scale.
Yeah.
So we need to have really good cooperation between universities, or I suppose institutions, and commercial growers. That would be helpful. There's a lot of things. There's a lot of barriers to that as well. But having at scale research also, it'd be great if we had technology innovation hubs like Europe,
Hmm.
like Delphi and Botany, these institutions, either nonprofit or profit, whatever it is their business model, but they're doing research in a high tech facility that is completely applicable. Leave it, the
Yeah.
universities will make the unique discoveries about plant physiology and breeding, and these would be more practical solutions. It'd be so great if we had something like that. I also think I'm really fixated on clustering greenhouses together so that you could get the benefits and energy savings from having some shared infrastructure, which might take
Oh,
public investment. But if you had, so I don't know what the formula is, co-locating with a data center and using the waste heat from a data center. You can use, there's all sorts of other waste heat sources too. There's glass factories, there's landfills, but we really need large areas of greenhouse, large acreage with multiple companies there, because then you could have like district heating where everyone's getting one source of hot water. And then
okay.
however you generate that with CHP or maybe using hot water from the data center. And then when you have that scale, what happens next is universities want to do research with you, community colleges and universities want to do training, on-site training and internships. So now you're building up the labor pool, and other ancillary, let's call them companies, to greenhouse and indoor farm operations begin to locate there. For example, if you're a robotics company and you've got five big customers in one place, it makes sense for you to put an office there. And now you're creating, and then same thing with people who make companies that make hydroponic gutters or other things. You begin to create this ecosystem and you get this efficiency, and you get just through osmosis, you get a little bit more innovation. People go out to coffee together. Maybe they have gatherings. I know these companies a lot of times keep their cards close to the vest, but I think you'd get a little bit more sharing because that has been identified as one of the barriers here in the US, whereas in the Netherlands, it's a smaller country and they're just close to each other. And here we've got these big facilities scattered all about, and there's really no organic way for the growers to kind of have a chance to share some pre-competitive information like, yeah, we like these new shade curtains or whatever it is. That's a long answer, but
I like that the efficiency of scale in terms of multiple greenhouse companies, operators being in the same location or region, so that all of the ancillary services and products are all also concentrated in that same area. And we talk about hubs sometimes, and
yeah,
Canada also has like Leamington.
they need to, right.
But I like that you added district heating and cooling because I don't think a lot of people think about that. But it's really almost like another utility. It's like having a gas pipeline or an electrical, the electrical grid. knocking at your door, or available to you to tap into, to heat and cool your greenhouse or your facility. And yeah, that creates a lot more opportunity, like you said, for heat recovery, and for, just efficient, heating and cooling systems in general. And one thing I think about sometimes with that is, you know, a lot of what drove CEA, or the interest in CEA, was to grow local, right? And to eliminate food miles and all that kind of good stuff. And so I think about that in terms of hubs, and if we have these hubs, all of a sudden it doesn't feel so local anymore,
Right.
right? It's
Mhm.
not in your
Mhm.
backyard or in your city or on a rooftop or whatever. But I think, even if I think about green building design, like LEED, it's local, but it's regional local, right? Like you can still procure materials, from 500 miles away. It doesn't have to be, hyper local. And so, to your point, like with these sort of concentrations of greenhouses and CEA facilities, I mean, maybe, we have five of them scattered around the country. Um,
Exactly.
yeah,
Wonderful. I
and they'll
love it.
cover 500 miles easy, right? Or
Yeah.
250 miles once they're separated by 500 miles, but that means that it's a 250-mile distance
Mhm.
between them. So, seems like it would still fit, right? The local drive for
Yeah.
agriculture.
I love that. I love the fact that there'd be in different regions of the country because
Yeah.
then it could serve the whole country, and then you could also take advantage of, I mean, maybe you'd have more indoor farms in one site and more
Sure.
greenhouses if there
Yeah.
would be a lot of indoor farms.
Yeah.
I'm thinking massive, like hundreds of acres of greenhouse, and indoor farms could be there doing a particular aspect of production that can't be done in a greenhouse. But you could also have like a Delphi Innovation Center there as well.
Yes. Yeah.
Now you've got a meeting place, and so that you could have gatherings. People come in from other areas, or globally, but also just a place for the local owners to get together for lunches or whatever it would be.
Yeah. I like that. So, Rob, that was the end of my official questions. So,
Huh?
I have a handful of rapid fire questions for you.
Fire away.
And which I did not share with you what they were going to be.
That's all right. That's what these are all about.
Yeah, exactly. So, one word, one sentence. If you want to expand on something, please go ahead, but they're
Mhm.
meant to be quick. All right. Are you ready?
Yep, I'm ready.
All right. What energizes you?
Learning.
Perfect answer. Can energy ever be balanced in a greenhouse or an indoor farm?
Yes, it will.
Okay. How much energy is too much energy?
The amount that puts you out of business.
Wow, that was really good answer. Are there any downsides to energy efficiency?
Not that I can think of.
Okay. If you could be any type of energy, what type would you be?
Visible light.
Yes. Those were so good. Your answers were so good.
Thank you. That
Well,
was fun.
well, Rob, tell our listeners how they can find these guidelines.
Mhm.
And if there's anything else you just wanted to mention quickly about RII and what they're up to.
Well, thank you. Thank you for that moment. We have a website, resourceinnovation.org. I think I got that memorized by now. And all of those best practices guides, we have a tab called resources. And you can go to our catalog, and all of those guides that we've mentioned and others are available for you to download for free. That's where you can find our information. Okay. And you can also contact me. My contact information is on there. I'm always willing to talk to folks. As you can tell, I love talking about greenhouses and indoor farms and energy savings. Some people want to know, how in the heck does RAI make money? And so I'll tell you that, because we like to be transparent about that. So we get federal grants, we get grants from states, we get contracts sometimes from states or from utilities or other operations to do specific projects where we write reports or we do other modeling for them. We're not really modelers like universities are, but something a little lighter. And then we have industry members who pay to be a part of this, and they tend to get first dibs on working group positions and such like that. And so that's how we stay afloat. That's how we break even. And we just want to thank all of those groups for sticking with us. This is a tough time for a lot of, well, it's a tough time for everyone. Let's be honest about it. And so we are weathering the storm of this tough time, and we're keeping a good humor about it. And we just really enjoy working with all the people we work with, because they're the kind of people like yourself, Nadia, who just want to share information. They see the bigger picture. Of course, everyone needs to make a profit and stay in business. It's the most important thing. But they also see a bigger picture. And my last comment is, I'm grateful for those people. That's what excites me. That's talking with people is what energizes me and makes this last few years of my career worth doing, and make me feel like I've hopefully will make the industry a teensy bit better than where I found it.
Well, thank you, Rob. I really appreciate all your contributions to the industry and for sharing what you've learned with all of us, and helping to educate and train the next generation and the current one, for that matter. So, Rob, thank you again for helping me kick off the energy series. I knew this would be fun, and we're going to have to come back and talk about water and talk about some of the other resources that I know growers are concerned about overusing. And a lot of the growers I talk to want to be good stewards of the earth and the environment, and so water is obviously a big piece of that, especially when it comes to agriculture. But today we somehow stayed focused on energy and still talked for a long time. No surprise there.
Great. I can't wait to listen to the other ones of this series. So good luck with those, and I'll be listening.
Thanks, Rob.
Take care.
You too.